Alright guys, so finally we are going to the last part of 2.1, which is ionization energy and the limitations of Bohr's atomic model. So ionization energy, I think you still remember that ionizing means you are removing your 1 mole of electron, kan? Okay, so the definition will be the minimum energy required to remove 1 mole of electron in its ground state. So electron awak tu di dalam ground state, which is n equals to 1 from an atom or an ion. Okay, you can remove electron daripada atom atau ion in gaseous state. So basically, if you don't remember this whole definition, you can remember this and then translate it into these words. Okay, so ionization energy punya definition ni memang tetap macam ni. Okay, kalau awak tertinggal 1 mole of electron, salah. Okay, if you don't say gaseous state, salah. If you don't say minimum energy required, minimum energy needed, salah. Okay, so make sure you get this right lah. Okay, so let's say when the hydrogen atom is ionized or remove electron from a hydrogen atom, okay, you will remove the electron that is in the ground state to n equals infinity. So n equals infinity ni, okay, kalau awak ingat, dia adalah the part bila awak punya line tu, energy level awak tu tebal. Okay, tebal, n equals to infinity. Ini adalah Y line, ini n equals to infinity. So this is actually the convergence limit atau convergence point. They're basically called infinity because, let's see, you have your nucleus, you have your shell, your shell, okay. So n equals to 1, let's say your electron is here, and then you remove it. Remove ke mana? You remove, bila you remove ke infinity, okay. Infinity maksudnya dia dah jauh sangat. So basically that's why when ionizing, okay, you remove electron, the n final, okay, will be infinity, okay, and final is infinity. So when you remove electron tu at n equals infinity, the potential energy of your electron is 0, okay, because awak punya electron is no longer attracted to the nucleus, okay, no nucleus attractive force on your electron anymore. So electron tu removed lah, it is free from your nucleus. So let's say okay, for that example here, this question saya tukar. Okay, for this question, macam tadi kita remove electron from hydrogen atom kan. So when n is equals to n1 is equals to 1 and n2 is equal to infinity, the formula that you're going to use is your Rydberg equation lah. Okay, so you can use this formula to find the ionization energy. Okay, so this is the first step. Okay, first you have to find the ionization energy. So masukkan je lah, maksudnya awak punya delta E will be in joules kan. So masukkan your Rydberg constant that is in joules, and then masukkan n1 which is 1 square, and 2 is infinity. So 1 over infinity square. So maksudnya jawapan awak kat sini apa? Your Rydberg constant bracket 1 over 1 jadi 1 lah, minus 1 over infinity. 1 over infinity will be 0, okay. So this one will be 0. So that means your answer will be 2.18 times 10 negative 18 joule. But remember, ionization energy, your formula pula, your unit will usually be in kilojoule per mole if mentioned, okay. Kalau tak mention pun, it's better to give in kilojoule per mole unless dia tak cakap, okay. So after finding the delta E, you will take delta E and times with your Avogadro constant, which is 6.02 times 10 to the 23 joule per mole. So after that, you will get your answer, which is 1312 kilojoule per mole. Okay. So that is the ionization energy for 1 mole of atom. Okay. Awak kali dengan Avogadro constant tu sebab kita nak 1 mole lah. Alright. So IE memang di kilojoule per mole. So this is the same thing. I think saya terbuat 2 kali kan ni. So you try doing that yourself. So besides using the formula Rydberg equation, okay, you can actually use you can actually find the ionization energy experimentally. Experimentally maksudnya kita guna line spectrum. Okay, when you are given a line spectrum, you can find the lambda infinity. So lambda infinity is the wavelength at the convergence limit right here. Okay, so bila awak punya electron tu kena remove lah. Okay, so we know this is the first line, okay, yang paling jauh. So don't take this value, but take this value, the one at the convergent limit. Okay, so for this example one here, it says the Lyman series of the spectrum of hydrogen is shown above. Calculate the ionization energy of hydrogen from the spectrum. So the formula that we are going to use, okay, will depend on the information that is given lah. So right here, the information given here is wave number. Wave number. Okay, wave number. And notice it has this times 10 to the power of 6 there. Okay, so just be alert. So kalau wave number is actually equal to 1 over lambda. Okay, so ini bukan lambda, this is wave number, which is 1 over lambda. So the formula that we can use, okay, is delta E equals to Hc over lambda. Kenapa kita guna this formula instead of delta E equals to H mu? Because we are not given the We're not given the frequency lah, obviously. Okay, so we use our wave number given. Alright, so this means that you are going to times your Planck constant with speed of light with your wave number. Okay, so wave number is already given here. You're going to use this one, the one at the convergence limit. Okay, so masukkan je lah value awak. It will be 6.626 times 10 negative 34 joule second times 3 times 10 to the power of 8 meter per second times your wave number 10.97 times 10 to the power of 6. Don't forget this one here, okay? Per meter. Okay, so nanti awak punya jawapan bila awak cancel the units, you will get it in joule. Okay, right, but that is not your final answer because your ionization energy must be in kilojoule per mole. So that means you're going to take that value tadi in joule tu sorry, times with your Avogadro constant, okay?